Many times when we're writing SQL queries, we need to perform a calculation on a set of values, but return a single value or a small set of calculated values instead of a standard collection of table rows. This often catches new learners off guard because SQL is usually introduced as a way to retrieve rows, not summarize data. Today we're going to dive into SQL aggregate functions and explore a set of inbuilt functions that standard SQL gives us to perform various kinds of calculations. I've provided some SQL scripts in the comments so that you can use and follow along step by step. We'll be using dbeaver, a free database tool to connect to a local MySQL instance. There will be a download link for dbeaver in the comments as well if you choose to use it. Please use the SQL tool that you're most comfortable with. Let's jump right on in and loading the simple database and data for our tutorial. After following the link to the sample SQL file we'll be using today and saving it to your computer, let's open it by clicking File, Open File, and then navigate to the location where you saved it. After it loads, let's click on the scroll icon here within dbeaver. In your SQL tool, it may be something different. Clicking on this will run the script. If we go over to Databases, right-click, and then refresh, expand the list, we'll see our aggregate database that's been created. Now, as you can see here, we have two tables. We have a student table, and if we right-click and select View Table, we can view the data. We can also right-click on Student Grades and view the data and see what's listed here as well. I need you to notice that the grade values for some rows are intentionally set to null. This is important because aggregate functions handle null values in a very specific way, and that's something we'll see clearly in just a moment. I'm going to open up a new SQL script by clicking on the SQL Editor menu item, then selecting New SQL Script. On the toolbar, we're going to ensure that the database is set to localhost and that our database is set to the aggregate database. With that done, let's type a simple query to test. Select all from student grades. Again, we can select the scroll icon or select the first play button, which will execute the line that the cursor is on. Here we can see multiple rows per student and a few missing grades as well. Now, let's start summarizing this data. So the obvious questions you might ask are, what are aggregate functions? What calculations do they perform, and how do we use them across multiple rows and return a single result value? The most common aggregate functions that are standard across all databases, these include the min, the max, the count, the sum, and the average. These are all standard SQL aggregate functions, and as I said, are pretty much the same across all databases. Now, these functions all compute in a manner by ignoring null values. There's one exception to this rule, however, and that is when we use the count all function, where we provide an asterisk instead of a column name. The count all function will count all columns and rows despite nulls. This is because the asterisk here is to include all columns. We'll get into this more in detail later. So let's go ahead and start with the min function. The min function returns the smallest value in a column. Here on this open SQL script, we'll type select min grade as lowest grade from student grades. If we run it, this query scans the grade column and returns the lowest grade recorded. Notice that the rows with null grades are ignored automatically. Let's rerun the initial query to see the difference. Here's the 76, which is the lowest. There are the nulls. Running the query again, we see the lowest grade returned. Let's jump over to the max function. The max function works the same way but returns the largest value. So again, we'll type select max grade as highest grade from student grades. Let's run the query. Looks like I made a mistake on the spelling. Let's rerun it again after correcting it. And here you can see there's the max grade. We can compare it again with our select all query, and we can see that true enough that 94 is the max. Now, this is commonly used for things like highest scores or largest payments or most recent dates. Let's jump down to the next one, which is for counting rows. We'll type select count. And before we continue, there's two important ways to use this function, and they both behave differently. Let's start with the count all that we mentioned earlier. Here, we'll type select count asterisk as total rows from student grades. When we run the query, we get a count of 9 rows. The count asterisk or count all counts every row regardless whether any column contains null values. Now, we can also run this query on a particular column. Here we'll type select count grade as graded rows from student grades. The key difference here I want to explain before we run this is that if there is any null in the grade column, it will exclude that from the count. Notice here, our total count is 9. But when we run this count on grade column, we get 7. That's because there are 2 nulls in the table on the grade column. This difference is extremely important and is a common source of confusion for many beginners. I think we can see the difference in how one counts all rows, including nulls, but the other counts the column, ignoring the null values. There's a third type of count that we can use, and this is called distinct. We'll type select count distinct, again, grade, as distinct grades from student grades. When we run the query, this again returns 7. You can use the count function to ignore duplicates by using the distinct keyword in the count function. If distinct is specified, rows with the same value for the specified column will be counted as 1. So let's look at the student grades one more time. Here we can see that there are various differences in all the grades. So the distinct count will be the same as doing a count grade. There are 7 distinct rows. However, if we change this query to use course name, notice that here in the course name column, there are differences. Let's run the query and see the distinct count of various course names. Here we see that there are 2. And again, you can see there's math, English, math, English, math, English. That makes sense when we run something like distinct course name in this query. Okay, let's jump to the next function, which is sum. The sum function adds together all the values in a numeric column. Let's go ahead and type select sum earned credit as total credits from student grades. Run the query. We can see the total credits is 2.25. Let's rerun the original query on the table. Here we see it's 0.25, 0.25 all the way down. Now, even though some grades are missing, the credits still add up because some is specified on the column earned credits and ignores the null values on the grade column automatically. We could rerun the query again by adding up the grades on the grade column. Sum grade as total grades from student grades. Again, we see the total value. Now, using the sum function here to retrieve this value may not make a lot of sense, but the next aggregate function, called the average function, is very useful on the grades column. Let's type select AVG grade as average grade from student grades. Run the query. And here we can see that the average across the grade column is 86.71286. The average function calculates the average value of that numeric column. So the average is calculated only using rows that have a grade value. Again, rows with null grades are excluded from the calculation. Let's do a side-by-side comparison with nulls. This is actually one of my favorite queries for teaching aggregate functions because it clearly shows how null values affect results. We'll type select count all as total rows, count grade as graded rows, comma, AVG, or average grade, as average grade. From, let's go to the new line, from student grades. Let's run the query. Here you can see the total number of rows, how many rows actually contain grades, and how the average is calculated using only valid values. This is often the moment where aggregate functions really will click for many students. Let's wrap up with a few crucial points before moving on to the group by and having keywords in SQL, which, by the way, are essential for expanding our use of aggregate functions. So aggregate functions summarize data instead of listing all rows. They return one value per calculation. And min, max, sum, and average functions ignore null values. This is very important. And what we also see is that the count asterisk, or count all, counts every row, while the count column name does not. We can take this a step further by combining the aggregate functions with the group by and the having SQL keywords to summarize data by categories like grade level and course. Let's take a look at some examples now. We're back inside dbeaver with the various queries we employed to learn how to use aggregate functions like min, max, count, sum, and average to summarize data. However, all of these examples, they all return a single row. But what if we want multiple summaries broken down by the category, like grade level, course, or student? Well, that's where the group by comes in. So what does the group by do? Well, the group by clause allows us to divide rows into groups and then apply aggregate functions to each group independently. You see, aggregate functions answer what is the summary, and group by answers with summary of what. So why do we need the group by? Why is it required? Well, SQL enforces a very important rule. If you use an aggregate function in your select clause, every other column in that select must either be aggregated or appear in the group by clause. This rule prevents ambiguous results. Okay, so let's start with a very common example. Here's the question. What is the average grade for each course? Let's type this out. Select course name, comma, and then let's use the average group by function on grade. We'll call it as average grade. And this will be from the student grades table. Now here's where the group by comes into effect. Remember, we have to say group by on the non-aggregated column that is in the select. So we'll type group by course name. Let's run the query. Here we see that the average grade for math is 85 and the average grade for English is 89. Now here's what's happening. The rows are grouped by the course name. The average grade is calculated within each course group, and null grades are ignored automatically. Now let's go ahead and do a couple other examples with the count aggregate function. Let's type select course name, comma, count grade as graded entries from student grades, group by course name. Remember that the group by column has to match what is in the select. So here we're grouping by course name, which is in the select course name. Let's run the query. Now, what this shows us is how many actual grades exist per course, not just how many rows. Let's do another example. Count all versus count by column name. We'll type select course name, comma, count all as total rows, count grade as graded rows from student grades, group by course name. Run the query again, and this makes it very clear which courses now have missing grades. Let's do another example using group by and the sum aggregate function to find the total credits per student. Now, let's answer a different question with this example. How many credits has each student earned? Think about that. Let's type out select student ID sum earned credit as total credits from student grades, group by student ID. We'll run the query again. And what we see is that each student may have multiple rows, but group by collapses into one summary row per student. Let's do another by using a group by and a join of two tables to get the average grade by grade level. Now, most real-world queries involve more than one table, and that's what we're going to do here. Let's calculate the average grade by grade level. So let's hit enter. Let's type select. S is going to be our alias. We'll identify it later. Grade level. Average of G, which will be our alias for student grades, but we'll say G grade as average grade. I'm going to hit enter and say from students S for our alias, join student grades as G. We're going to join it on the S student ID, where G equals student ID. We'll enter one more time. Group by S grade level. Now, before we run the query, this is obviously more complex than what we've done before, but it still follows the same rule. What we're selecting from is still in the group by. Let's go ahead and execute the query. And here we see that we've joined students to their grades, we've grouped by the group level, and calculated the average grade within each grade level. Let's consider another example. What would make a query fail? Okay, sometimes it's best to learn by mistake. So let's do something that will fail and then fix it. We'll type select course name, student ID, average grade as average grade. This will be from student grades, and we'll group by course name. Can you see what would cause this to fail? Go ahead and click Run and see what your tool, your SQL tool, tells you. When we click on the errors, we see, as it displays, the select list is not in the group by clause and contains no aggregated column. Aggregated demo student grade student ID, which is not functionally dependent on columns in the group by clause. This is what we expected. We're grouping by course name, but we're not grouping by student ID. So this fails because the student ID is neither aggregated nor included in the group by clause. And SQL doesn't know which student ID to display in this instance for the course. How do we fix it? Well, we can either remove the student ID or add it to the group by. So let's do that. We'll add it to the group by. We'll say group by course name and student ID. Let's run the query again. Now, the grouping is unambiguous. We can see that each student ID is grouped, each course name is grouped, and we see the average grade for that student for their courses. A helpful way to think about the group by is for each unique value in the group by column, it returns one row. Take a look at the screenshot from the last query we ran. Notice that math, student ID, and average grade align. Each unique value in the group by column returns one row. And that's actually what you see here. There are some key takeaways for using the group by. First, group by lets us calculate aggregates per category. Second, every non-aggregated column in select must appear in the group by. And third, group by works seamlessly with joins. The last important note is null handling rules stay the same. So I have one final SQL demo, and then we're going to wrap this up. This involves using the having keyword. So here's the question we want to answer in this final demo. Which courses have an average grade of 85 or higher? This is an important distinction. We're filtering on an aggregated value. The where clause cannot do this for us, but the having clause can, because it was designed specifically for this purpose. Now, let's demonstrate an anti-pattern where this will fail. So we'll type select course name average grade as average grade from student grades where average grade is greater than or equal to 85. Group by course name. Now on its surface, this query looks like it's totally fine. Let's go ahead and execute it and see what happens. And as you can see, there's an error. The reason this query fails is simply because the where clause is evaluated before the aggregation happens. What that means is at this point, the average grade does not exist yet. So let's go ahead and correct it by using the having clause. I'm going to simply select this portion and cut it, paste it on the last line, change the where to having. Now, let's execute it again. So first, the SQL groups the rows by course name. Then it next calculates the average grade for each group. And then finally, the having filter groups the results, keeping only courses where the average grade is higher than 85. What this will show in return is your English and math scores, depending on what the average is, and null handling. And notice that null grades are ignored automatically when calculating the average. Let me give you a couple of simple rules for this. The where clause filters rows before grouping. The having clause filters groups after aggregation. Remembering that will save you some head scratching later, believe me. We have one last question to consider. Can we use both where and having together in a SQL statement? Absolutely. Let's combine where and having in the previous query. Here we have select course name, average grade as average grade from student grades, grouped by course name having average grade equal or greater to 85. Now, we can still use the where clause here, but we have to limit on what we're filtering on. We can't filter on the aggregate value. We can filter, though, on whether the grade column itself is not null. Let's run the query and see. Now, this may look like it hasn't done anything, but in the background, the where clause filtered the individual rows first. Then the having filters summarized results afterwards. Once you understand where, group by, and having as three separate stages, aggregate queries become much easier to read and write. Listen, I'm aware this video was fairly long, and to be honest, I didn't even cover all the various ANSI SQL aggregated functions yet. All of these scripts are linked in the comments, so please feel free to download them and run through these tutorials again on your own. If you made it this far in the video, leave me a comment. I get it now. Or not if you don't. If you haven't subscribed to my channel, please do, and like and click that bell icon as well. Guys, thank you for watching and sticking with me through this tutorial. I'll see you in the next one. Blessings.